This is also called the first derivative test. If at the critical number, the derivative changes sign this way, or it's undefined here and it changes sign this way, it's a relative max. If at a critical number or where the function is undefined, but the derivative is undefined, but the function has to be defined, otherwise, what's the point? Then this sign change, or this sequence of signs, is equivalent to a relative min, and that is the first derivative test. Okay, which comes into play a little bit later, but I can't wait. I have to present that in the correct order. Okay, so I'm going to choose a function, and then you can choose the next if you like. And I close my book. Okay, so let's start with, oh, I already have the function. Sorry, I already have the function. I already chose a function. And we can choose the next one after that. Okay, so I have to copy it here. So g of y minus 1, y squared minus y plus 1. Okay, so the question is asking us critical numbers, max min, analyze. Okay, good. What do I need to find first?
G prime of y.
G prime of y. Excellent. Okay, what do we have to use?
The quotient rule.
Thank you. Okay, good. So we have to square the denominator. We differentiate the top. Luckily, is 1 minus top stays as is, and I differentiate the denominator to get 2y minus 1. Again, if you don't distribute or try to factor if it's possible, or if you're getting with the flow or something, and you decide to simplify this, that would be a tragedy. So please remember, don't touch the denominator. I still see many of you expand the denominator. We said that several times. Please do not expand the factors in the denominator. Okay, so then y squared minus y plus 1. So it doesn't matter how you want to do it. So y times 2y with minus in front, minus 2y squared. Y times negative 1 is negative y with minus in front. Negative 1 times 2y is negative 2y, so positive 2y. And negative 1 times negative 1 is 1 with minus in front, negative 1. So we have to try to clean it up as much as possible. And this is what I asked you to do in chapter 3. Simplify it to the fullest, because you already figured out what I'm going to do next. So in descending order, this is negative y squared. These, luckily, they go away. These two go away. Nice. And then I have plus 2y. Everything over, y squared minus y plus 1 squared. So this was our first step. Can anyone explain what we need to do in step 2?
Set are equal to 0?
Yes. So in step 2, part A, I have g prime of y set equal to 0. And in part B, I have to analyze g prime of y being undefined, if that's the case. But I have to look at both possible sources. For any function, I have to analyze both possible sources. Okay, so when I say this equal to 0, look at this and tell me what to write. When is a fraction 0?
Set the fraction equal to 0.
Yes, when is a fraction 0?
Oh, and
denominator 0.
Careful, that's for undefined.
Oh, when the numerator is 0.
When the numerator is 0, very good. Good. So, of course, I will multiply by -1. You know I'm allergic to negative leading coefficient. So y squared minus 2y equals 0. So I'm continuing here. Factor out y. And we get two options. Y equals, y equals. Anyone?
2.
Yes?
0.
Good. So there are two critical numbers. Y equals 0 and y equals 2. Good. Now, let's analyze. So we already found from source A, we have two critical numbers. Fine. From source B, y squared minus y plus 1 is never 0. So let me show you again. How do I know this? It's because it's a piece of y cubed minus y cubed plus 1. Okay, so that's why I know. But you don't have to remember that necessarily. But then we go to the calculator, use the feature, the app. As I mentioned, I'm expecting my students to know how to use the quadratic formula. So the leading coefficient is 1. The middle coefficient is -1. And the last coefficient is 1. And when I try to solve, I'm just curious. That's why I wanted to see if it gives, okay. So it's still, my TI-86 is still better because the TI-86 not only will, so the TI-86 has something called a poly feature. I don't have a simulator for TI-86. So TI-86, but you don't have to purchase a calculator now. So it puts the order, which is 2, or degree, same thing, and the coefficient is 1, then -1, and then 1. And when I click solve, it also gives the complex solutions. It says 0.5, comma, 0.866, 0.5, comma, -0.866, which means 0.5 plus I 0.866 or 0.866 times I, and 0.5 minus 0.866 times I. So I don't know why they discontinued this calculator a long time ago, a long time ago, at least 15 years ago. Okay, so enough of that. So there are no solutions here, so I will write no solutions, no real solutions. So this particular function has critical numbers only coming from the first source, not from the second one. Fine. The next step is very important. Please, I will always accept other methods, but please just this once, bear with me and use this method. Okay, so we have y, which is the independent variable. We have g prime of y, which is the derivative. And we do have g of y. So y is the independent variable. G prime is the derivative, and you'll see what happens here. And g of y is the function itself. This function is always defined, so the denominator is never 0, so the domain is all real numbers. All I need right now to discuss is y equals 2, y equals 0, and y equals 2. In the row for g prime, what should I write under 0 and under 2? I know it's a silly question, but I just need to make it very clear.
0.
Of course, that's how we got these. Thank you so much. Exactly. Perfect. In the next step, I will study the sign of the derivative. How do I study the sign of the derivative? I look at the derivative first of all. And my props are not ready. Now they are. There is no point in discussing the denominator when it comes to the sign. Why?
It's always positive, right?
That's it. Forget it. It's not going to change the sign. Now the numerator is the same with negative y minus 2 over something squared. Who cares? So I already know the solutions, right? 0 and 2. I know that the leading coefficient is negative. So obviously, this numerator looks like this. But I'm not graphing the function or anything. I'm just discussing the sign of this expression. And it's obviously that this is the case. Let's say I don't want to think in those terms. Fine. In that case, in the numerator, let's plug in a number to the left of 0. Y to the left of 0. I want a number here to the left of 0. I want a number here, and I want a number here. I already know the answer because it has a maximum, right? That piece, just that piece. So this has to be negative, positive, and negative. But let's say I don't want to think in those terms. Maybe some of you may say, this is too complicated. What are you graphing here? Well, I'm only discussing the sign of this expression, which is a quadratic function with a maximum because the leading coefficient is negative. And I know it crosses at 0 and 2. So this left of 0 must be negative. Right of 0 must be negative. Between 0 and 2 must be positive. But let's say we don't want to do that. Fine. Then let's plug in negative 5. Negative 5 minus 2 is negative, negative, negative. 1, 2, 3 negatives. Well, 3 negatives, when I multiply them, I have to get a negative. Now let's say I'm here with 1. 1 minus 2 is negative, negative, positive, negative. 2 negatives, obviously. And then I'm going to plug in 10. Positive, positive, negative. At this point, I have to plug in the function value 0 to determine the y-coordinate, value 2, x equals 2 or y equals 2, and find the y-coordinate. Okay, so let's see, where is my function? Like 3 pages ago? Yeah. Okay, so when I plug in 0, that's easy. 0, 0, 0, I have negative 1 over 1. No problem. Let's see what I get when I plug in 2. 2 minus 1, I can do it right here, g of 2. 2 minus 1 is 1. 4 minus 2 is 2. 2 plus 1 is 3. So it's 2 squared. 4 minus 2 is 2. 2 plus 1 is 3. Done. At this point, you can say, well, what are you talking about? Because you don't know where this function is going here. True, I don't. And we don't need to analyze that at this point. But we will have to determine this limit. And this limit. Let's do it. We know how to do this. It's been a while, but like 3 weeks. So x approaches negative infinity. This is always something that has to be determined at all points in time. Same thing here. So let's do this. Let's not procrastinate on this because I need it anyway. Okay, so I need to determine this limit. What do I have to do first when we determine such a limit? When we determine any limit, what do we do first?
Do we plug it in?
Yep. So what is the highest, what is the degree of the numerator?
1.
Good. So when x approaches negative infinity, where does the numerator go? Because this is too small to mention.
Negative infinity.
Good. What is the degree of the denominator?
2.
2. So then the most powerful one dictates at infinity. So where is this going?
Positive infinity.
Good. What do we do in a case of infinity over infinity or 0 over 0?
Undefined.
Careful.
L'Hopital.
L'Hopital. Which, by the way, is in chapter 4. So we have a head start. Good. So can anyone give us the derivative of the numerator?
1.
Can anyone give us the derivative of the denominator?
2y minus 1.
Good. Can anyone plug in infinity again and give us the answer?
No. So is L'Hopital's rule we take the derivative of the numerator and the denominator?
Do we have 0 over 0 or infinity over infinity?
Well, yeah, I understood that part. It's just it's been a while
No,
since
right.
we did
No. Right here at this stage, do I have 0 over 0 or infinity over infinity?
No.
No. So I cannot use L'Hopital's rule now.
I was talking about for the first step.
Yes. So the first step, as long as I have 0 over 0 or infinity over infinity, I can use L'Hopital's rule. And what is the answer now?
0.
Very good. In the same way, we get 0 here. What do we conclude? What do we say? Y equals 0 represents
Asymptote.
horizontal asymptote for this function. Okay, finally, I want to check that my work on this row and this row is correct. Okay, so what does the function do between 0 and -1? Goes up or down?
Down.
Good. Is that supported by the sign of the first derivative?
Yes.
Correct. Between -1 and 1/3, what does the function do?
Goes up.
Good. Is that supported by the sign of the first derivative?
Yes.
Good. From 1/3 to 0, what does the function do?
It goes down.
Good. Is that supported by the sign of the derivative?
Yes.
Perfect. So now here's what we have. There is a critical number here. 0 is a critical number. And this derivative changes sign in this way, from negative to positive. What type of point is 0 comma -1? 0 comma -1. What type of point is it?
A minimum?
Yes, a relative min. Perfect. What about the point 2 comma 1/3?
Max.
Relative max. So it turns out that for this function, we found two critical numbers. Both of them change into max min respectively, because the derivative changes sign, left and right of the critical number. Any questions on that?
So you find the critical number and then you plug that into the regular equation, and that gives you your relative max and min?
The y coordinate. But it doesn't tell me whether it's a max or a min. The sign of the first derivative does. So when you found 0 and 2, you plug them in a function to find the y coordinate of the point. But that does not mean that this is a relative max or relative min. No. You have to study the sign of the derivative. That will tell you that 0 comma -1 is a relative min because the sign of the derivative is negative and then positive.
And just to double check, when the derivative is negative, then it's decreasing.
Correct. That was the next thing that I wanted to write. So the function is decreasing when the first derivative is less than 0. the function is increasing when the first derivative is greater than 0. Very good. Next question. I think somebody else had a question.
Yes.